In this lecture, we focus on measurement and a few other related topics. Eventually, we're going to need to measure something, more especially our dependent variable, and we're going to need to collect that data to do our research. Our chapter and lesson are just a cursory view on measurement. The field of measurement is broad and deep. We are going to focus on just a brief introduction to the topic. We're going to start with an intro to measurement and scales, discuss the three pillars of measurement. So we'll focus on some reliability, a little validity, and just a few notes on fairness. We'll mention tests and inventories used for measurement, and then briefly go into some data preparation, but we're going to follow up on that on our next several lectures as we get into some statistical analysis in descriptive and inferential statistics. In this lecture, we will not be investigating the complex mathematical underpinnings of the topics. We're just going to be discussing issues around measurement. But do know that the field of measurement is layered with some complex modeling, deeply ingrained in statistical analysis, Bayesian and probabilistic thinking and reasoning, and many modern measurement techniques. So if you are interested, we have several courses that just investigate measurement theory, also known as psychometric theory, which provides the foundation for evaluating educational measurement. There are many types and methods of measurement. We can just really think about what we want to measure in our research. And often we want to measure our dependent variable, which can take on many forms. We're going to see that some of the typical measurement devices used in educational research are tests, inventories, and observational schedules. We'll come back to those later on in the lecture. Before we get started in measurement and talking about testing and inventories and assessments, let's go back all the way to the beginning again. Why don't you grab your hypothesis, your research questions, and follow along so you can be thinking about ideas of reliability and validity and what you might use as an assessment as we go along. So just as a recap, as I'm thinking about my topic area for healthy eating and learning, derive a research question that I want to know something about healthy snacks and their impact on children's mathematical abilities, and develop a research hypothesis around eating healthy snacks, defining apples, and a mathematical assessment. Well, what is that mathematical assessment specifically? How am I measuring? What is the reliability and validity of that instrument? If you haven't done so already, you should be thinking about how you're going to operationally define your dependent variable. In my research hypothesis, I'm looking at a math assessment. That math assessment is going to be connected to some ideas so that we believe in that math assessment. So it's going to have evidence for the reliability of that assessment or test, and things like evidence for the validity of that test. And we're going to learn a little bit more about those concepts as we go through this lecture. So have your idea, your operational definition of what you're measuring, more especially as your dependent variable, but just anything that you're taking measurements of. And we'll consider the topics as they come up using your example as well. So take a pause moment and grab your hypothesis, grab your research questions, and try and think about these ideas in the context of your research. In classical measurement in the physical sciences, one of the standard ways of discussing and defining measurement is that measurement is the determination or estimation of the ratios of our quantities. But this is a problem in the social sciences and education, where it may be difficult or impossible to build ratios. A much more current and widely used definition of measurement is the process of assigning numbers according to some rules, numerals according to some rules. These values are assigned to objects or events such as responses to items or certain observed behaviors. We'll attribute this actually back to Stevens in 1946, and also the adaptation of that to Lord and Novick in 1968 and Tergerson in 1958, where a simplification of this we can think of as assignment of numbers to properties of objects according to a specific rule. So it's not to the objects themselves, but to the properties of those objects. In considering the types of measurement scales, start off with this idea of scaling, in which it's the development of systematic rules and meaningful units of measurement. The name scale sometimes in areas applies to a particular instrument, which is a test. That is not what we mean here by scale or scaling. So we do mean the development of our rules and meaningful units of measurement. It's a set of possible values with some assignment rule. Scaling rules don't have to be that complicated. We're just linking elements in our data system to elements in the real number line. So the rules tell us how to assign those numbers. And the data system, we want to cover all possible observations for the given properties of the object we're interested in. So when we're scaling values, scaling rules and the numbers are assigned to each element in that system. And we'll look at that as scales of measurement, and that'll give us some context about what numbers mean. Now, more concretely, when we think of scales of measurement, we're thinking of classically these four scales: nominal, ordinal, interval, ratio. Those are the four scales of measurement we'll talk about. And there's a hierarchy to these levels that we will discuss with increasing characteristics. Let's start with the nominal scale. We might think jelly bean preference, your flavor or color, or maybe you think your favorite soda or soft drink. We are going to categorize things without any order. So it's the qualitative labels. We can classify and count things. We could count the number or color of jelly beans. We could classify things into preferences or types, such that they're mutually exclusive and exhaustive. We also say that there's a transformation that can occur that's isomorphic. So if we label something 1 and 2, if we label the red marble as a 1 and the blue marble as a 2, if we were to systematically reverse that rule, that would be okay. We wouldn't have any error in our assessment or measurement, as long as we continually did that. So if red is 1 and blue is 2, that's okay. If we reverse that, that's okay, but we have to stay constant. We can't do both at the same time. When I say mutually exclusive and exhaustive, that just means exhaustive means we cover all of the possible categories that exist. And exclusive means that one of these instances can't be in multiple categories. So if we label jelly beans as red or blue, exclusive means you can only put them in one of those two categories, and exhaustive means we would cover all of those colors of jelly beans that are possible. Next up is the ordinal scale. We retain the same properties of the nominal scale. That is, we're giving things characteristics, we're saying they're mutually exclusive and exhaustive, but we're adding one additional property. That additional property is that we have some form of logical order. So we can think about the magnitude or amount of a property, but it's in some sort of rank order. We can transform our data, but it needs to preserve the order. That's all monotonic transformation. Fancy way of saying that is monotonic transformation. But we can multiply by 10 if we wanted to. If instead of first, second, and third, you could say 10, 20, and 30, as long as we preserve the order. Some really good examples, you maybe think of some sort of race, like a horse race, where we have first, second, and third, but there's no time ranking, there's no equal interval, just that we say somebody comes in first, a horse comes in first, second, or third. Your letter grades, difference between an A, B, or C, are just simply ordinal. There's not an equal distance between those values. We also can think of ideas like our socioeconomic status or education. So maybe we have ordering like low, middle, or high. Maybe we have education levels like some high school graduates, some college, trade school, associate degree, bachelor's degree, through master's and a doctorate. You can rank order those education levels, but there's not an equal distance between those things. In addition to all of the qualities of the ordinal scale, in an interval scale, we have equal distance. So that means there's an equal difference in quality reflected on the scale. We know exactly the difference between any two of our measures. Here I have an example of the GREs and also an example of a thermometer. So for the thermometer, we know the difference between 30 and 40 is the same as the difference between 40 and 50. We also say that in an interval scale, we can do a linear transformation and still retain all of the same properties. Without getting into the math in that, we can just think of a linear transformation as going from the Fahrenheit scale to the Celsius scale. So we see both scales there side by side. We can transform back and forth into the one or the other, and we still have the same meaning and context. We still retain all of the properties we had from the nominal, ordinal, and interval scales collectively. Our final scale is the ratio scale. In addition to all of the qualities encompassed in the interval scale, we also have an absolute zero, which is the absence of equality. The only type of transformation we could do on this is with a constant. We need to retain that ratio scale. How we choose to measure matters. So I'll just use temperature as an example. Fahrenheit and Celsius are both interval level scales. They can go from positive, in theory, from positive to negative infinity. They can measure water freezing and water boiling. But one of the issues with those scales is that when we attribute a zero, for example, on the Celsius scale, that is not the absence of temperature. It is not the absence of something. That zero is just another point on the scale. The same thing holds true with the Fahrenheit scale. Whereas in the Kelvin scale, absolute zero is the lower limit of thermodynamic temperature scale. You can think about it as movement stops at that point in the Kelvin scale. So that absolute zero is a point at which, from a physics perspective, fundamental particles of nature have minimal vibration or motion. It means something. It is the absence of something. Whereas on those other two scales, they are only interval level scales because the zero does not have the same meaning. You could transform those to look exactly like the Kelvin scale, and then they would become the Kelvin scale and become a ratio scale. But unless you do that, you have an interval level scale. And the reason I say this is because most of the scales that we deal with, even though they look a lot like a ratio style scale, in education and psychology, the best type of scale we typically have are interval level scales for most of those things that we measure as our dependent variables. Just for a quick recap, the reason we think of this as a hierarchical scale is at the very top, our nominal scales, the most important characteristics are things like they're mutually exclusive and exhaustive. We create these categories, these bins, where you can only go into one of those categories, whatever you're interested in measuring, the properties of the object you're interested in measuring, maybe its color or shape or size. It can only go into one of those categories, and we need to cover all of the categories. So we start with nominal, and to move to the ordinal scale, we add order. To move to the interval scale, we now have an equal distance amongst those orders. And to move to the ratio scale, we have absolute zero. So this hierarchical levels of scales build on each other. There's a lot of debate in the literature about what we measured and how we can use it. Some of the trouble with numbers is that we go from numbers to what we think we measured. When we try to answer a measurement question, it's important to know about the links and connections, the rules that we used, because the numbers don't know where they came from. People say things like, we'd like to use a different specific type of analysis, there's assumption issues. We're not going to get too deep into those issues in measurement here, but you should know that on one side, individuals will look to say that you can use only specific types of measurement with types of analysis, whereas others will say maybe you can go as deep as using an ordinal scale when you're looking at using a statistic. And what you really need is a clear rule system and be able to explain why those numbers have meaning. There are desirable characteristics of our test. When I say tests here, I mean our measurement tools, our tests, our inventories, our surveys, even a ruler that you might use. There are 3 pillars to which we build our tests toward that help us understand some of the issues we might have when we're trying to assign rules and come up with the believability of our measurement system. These 3 things will help us articulate and understand the desired characteristics we would like to see in our assessments. The first we'll talk about is reliability. Just as a way of thinking, not too technical about reliability, you can think about consistency or repeatability of the results that you have, the measures that you're making. Validity measures what we intend to measure. We provide evidence to support that our measurements are actually measuring what we intended to measure. And fairness, we want to make sure that we're unbiased toward any gender, ethnicity, issues around language, or disability. These are the 3 characteristics of a test that we explore to help us believe in the measurements that we're making and the development of those measurement tools. It might help to mention what a test is broadly defined. I'm going to use the definitions from the Standards of Educational and Psychological Testing. The standards are used to provide criteria for the development and evaluation of tests and other practices. When we say tests, we also mean tests and scales, assessments, inventories in general. Like, for example, it could be a paper pencil exam, but it could also be a test or assessment involves gaming, a martial arts advancement, musical performance assessment, a flight simulator, maybe an optimism inventory. So we can think about all of these things as generalized assessments and tests. So the standards provide some guidelines for us to help us interpret and assess the validity of the statements we want to make about those assessments. So a test is just a set of tasks or stimuli. You could think, I have a bunch of items or I have a bunch of questions, and they are designed to elicit responses that provide a sample of an examinee's performance on a specific domain. We basically want to score and interpret the work that they provided. The work that they provide might be a written test. It might be a survey questionnaire that we're looking at. It could be observational assessments. In general, though, we'd like to know the reliability and validity of the interpretations that we're going to make about those individual scores. We're going to first dive a little bit into reliability. Some people collapse together reliability and precision in measurement. Whenever we discuss reliability related to the instruments or tests that we're using in measurement, we're always going to talk about it as evidence for how we use those tests. Not the evidence, not the reliability of a test, but instead it's the evidence of reliability for how we're using that test. Because if you use a test incorrectly, you don't really have the same level of evidence for that test. Its reliability, its repeatability, how well we can replicate the scores. So reliability and precision, some people talk about the consistency of scores across instances of the testing procedure. We're also going to focus really in on reliability coefficients, which is the estimates of reliability in our readings. We can think about consistency or reproducibility. When we have the same individual circumstance, we would expect the same results. And consistency, we would expect just there to be over many administrations. All of the reliability definitions from your textbook all come from this idea of classical test theory. We're not going to dive too deeply into that. We're going to stay at the very surface area, but kind of give the analogy here Learning a little bit about classical test theory is like learning a little bit about ancient Greek philosophy, in that you may have learned very, topically about ancient Greek philosophy, Aristotle, Socrates, but you haven't deeply touched on those areas if you've just taken an intro to ancient Greek class. So it's the same thing here with classical test theory. It's useful as a source and as a starting point, but you really want to dive into, in philosophy, you'd want to get into Western philosophy, other Eastern and Indian philosophy, African philosophy. You want to get into modern and contemporary issues. Same here with classical test theory. If you get more interested, you're going to want to dive into modern measurement theory, item response theory, generalizability theory, diagnostic models. So there's a lot of other areas. We're just going to touch the surface just to give us some intuitions about what we're doing with reliability. The reliability of measurement. We can really think about this as consistency of an instrument in measuring whatever it's supposed to measure. Every time a test is given to a specific subject, we should see that the results should be approximately the same, especially when it's for the intended purpose, the intended use. For example, instead of telling you about a test, here's a piano. If someone goes to play a piano, an instrument, every time that individual goes to play that instrument within a very short range of time, at least, we would expect results to be similar. I say within a short range of time because people, just like in research, there can be improvement. If I decide to go take piano lessons, or if I was an expert playing piano, maybe I played when I was younger, as I get older, I may not be as good anymore. So in general, what we expect to see is consistency over a reasonable amount of time in those measurements. You may also think repeatability and consistency together. I often think, when I think about reliability of a test, I think about pilots, pilot simulators, pilot licensure and certification processes that they go through, and that those assessments are evaluating them, that they will be consistent over time and successful at what they do, so that when you get on an airplane, it's not just the instrument, but the individual using that instrument. So it's not just the plane, it's also the individual flying that plane. You expect that performance will be similar from time 1 to time 2 to time 3. There will be a lot of consistency and repeatability. You sure wouldn't want to get on a plane with an instrument that was inconsistent or not replicable. So sometimes the plane flies correctly and sometimes it doesn't. We would not want to get on that airplane. In classical test measures and classical test theory, there are several empirical procedures we use. We're going to talk about a lot of our reliability as reliability coefficients. So those empirical procedures we use to derive reliability yield a reliability coefficient. Well, our reliability coefficients just simply range from 0 to 1. We're not going to get into the details of how we derive those zeros and ones. Again, if you're interested, I can point you to other sources. But 0, the meaning of 0, means that there's no reliability in our instrument. A 1 means perfect reliability. In practice, all tests have error. So we really are never likely to see a perfect 1 or no reliability 0. As a matter of fact, if I ever see either one of those in practice, I always assume something has gone wrong with the math or the testing. So I would verify my data. I would examine my data and the results. In estimating reliability, there are different forms and methods for estimating reliability under the idea of classical test theory, under the way that we're looking at the basic estimates of reliability here in class. One way of estimating reliability is that we just use one test administration and we get measures of what we call internal consistency. So reliability, when we just have one test, we measure it, we try to derive reliability. We call that a coefficient of internal consistency. And then we may also have 2 or more parallel forms that we can administer of a test. And we might talk about that as a coefficient of equivalence. The first form for estimating reliability is parallel forms. These are parallel or alternate forms where individuals are given one form on the instrument initially, and then they're assessed with a second alternate or parallel form on the instrument. You could give these forms back to back since there are two different forms. If the test is considered reliable, then the patterns of scores for individuals should be the same, or really should be similar for the two forms of the test. So we should see high positive associations between the scores. That just means, like in a correlation between the two forms, we should expect to see values close to 1. The test-retest procedure is another way. This time, instead of parallel forms, we have the same test. So the same test is administered to a group of individuals twice. The reliability coefficient can be calculated just by correlating the performance on the first administration with the performance on the second administration of the test. Another way to estimate reliability is a procedure that we use, a split half reliability. So you can just envision administering one test. We give that test. Once it's done, we split it in half in order to determine its reliability. So the items of the two halves, so half 1 and half 2, they are matched on their content and difficulty. We then do the same kind of thing that we did with the test-retest or the parallel form. We're going to correlate these things together. So we take the test is reliable, we consider it reliable if there's a high positive relationship or correlation between the two sets of scores. So in this way, we sort of take one test, but we treated it as if it were two and try to relate it to each other, and we expect to see high performance on each halves of the test. The Kuder-Richardson procedures, we'll discuss two of the formulas that they use for estimating reliability. Actually, we're not going to discuss the actual formulas, just the ideas behind them. So there's one test administration again. The two formulas that we can use depend on the decision to use either, depend on the characteristics of the instrument that we're using. But in the case of KR20 and KR21, KR is for Kuder-Richardson, they're both binary data, 0, 1, you can think of correct, incorrect type data. So KR20 provides the mean of all possible split half coefficients. And KR21 can be substituted for KR20 if it is assumed that the item difficulties are similar. You very infrequently see the KR formulas reported, and the reason why is because of Cronbach alpha. The Cronbach alpha procedure is the generalization of those KR procedures, because not only can we use it with binary data, we can also use it with all our other forms of instruments with other polytomous responses. So this is the most likely measure of reliability estimate that you will see for one test administration. So I like to think of this mathematically as doing all possible split half procedures, and then you average out the outcomes, and it doesn't matter whether you had correct or incorrect or partial credit models, or you can even use this with our survey questionnaires as well to get back a measure of reliability, a measure of internal consistency of the instrument that we're using. Just within classical test theory, just within one theoretical structure, just as a very brief introduction to reliability, we already see that there's multiple ways of understanding reliability. There are different procedures and measures that we can use to develop the estimates of reliability. How much do we believe in the repeatability or consistency of our test? And those procedures, we saw those that were based on one test administration for internal test consistency, and those with multiple administrations are our tests of equivalence or stability over time. But with the responsible use, we have to consider more than just reliability. So reliability, we would say, is a necessary part of developing a test, but it's not sufficient. We want a strong rationale for our test scores with reliability, validity, and fairness. So we always talk about reliability as a evidence for the reliability of the way we're going to use the test. And this gives us inference about how the test is to be used and how much we believe in the consistency of those scores. We want to make sure that inferences about the test are still correct. That is, even though a test is reliable, it may not be valid. A just short example as we move on into validity. An example of an assessment, a test, an instrument that's used that is reliable but not valid comes from phrenology. So it used to be that we would make claims and statements about individuals based on lumps or indentations in one's head. One would have a phrenology bust, as you see in this picture. One would feel for lumps and curvatures of your skull. And they would make a claim about you. They would make an inference about you based on the bumps that they found. Well, this instrument is reliable. I'll just sit that out there for a second. It's a reliable instrument. That means it's consistent. If I were to come back to it, I would get the same measurements again. If you and I were moderately trained in phrenology, we both could touch different areas of a skull and we would feel the bumps and inconsistencies on that person's head. But it is not valid. It does not do what we expect it to do. It does not measure what we intend it to measure. That is, it doesn't matter personality traits or intelligence traits. It just measures how lumpy our heads are. So in this case, historically, this is a pretty good example of an instrument that was reliable, but it was not valid. So we're going to move into validity now to try and understand the types of inferences we want to draw and the extent to which an instrument measures what it is designed to actually measure. I also always like to show at least one version of this arrow chart for reliability and validity. You see, you could probably go online and do your own reliability and validity study just on these types of precision, reliability, and validity tables that you find or graphics that you find. So a really good example, the first one is our reliable but not valid. We see things clustered close together. That is, the person shooting those arrows or darts are getting accurate to the same point. It's reliable, to the same point, but it's not valid. It's not hitting the target. The second bullseye shows low validity and low reliability. There's just distribution everywhere. There's not any clustering. You're just kind of throwing them up there and they're going all over the place, and it's not targeted. But it's a low validity. It's not no validity. The next third bullseye is both not reliable, it's distributed far, and it's not valid. It's not even the target is not. If you were to average those scores over, you would not see that it is a valid instrument. And then finally, for reliability and validity, we're trying to center it in the target, and the target is appropriate. So this is just graphically a good use of reliability and validity, just to give you some intuitive. This isn't to give you the definition. This is just to give you some intuitions about what we mean by reliability and validity. And when they coincide, we're hitting the target of measurement, and we're hitting it in a consistent way. With validity, we'll start with a little bit simpler and classical definition here. We think of the extent to which an instrument measures what it's supposed to measure. So we also tie it to its intention and use. That is, a test could be highly valid for some situations and not others. We can think about our scale, maybe measuring weight. If I get on a scale and I measure my weight and I tell someone I weigh a certain amount of pounds, then the scale's instrumentation, it's being used as it was intended to for what it's supported to measure. But if I get on a scale and tell you, I don't know, my IQ is 200 pounds, you're going to say, no, that's not what the scale was intended to measure. It doesn't measure your IQ. It measures your weight in pounds. So not only does the instrument measure what it's supposed to measure, we also have to think about it conditional in its use. And we have to be cautious not to extrapolate to conditions of measurement that it wasn't intended for. In that perspective, we always talk about validity as evidence. It's an evidence gathering process. It's a collection of evidence to support the types of inferences drawn from test scores. So what are we saying about people? Maybe something about weight, as in the previous example. You want to be able to, you need to collect evidence for those intentions and use of your test. It's not just saying my weight, my scale is valid. It's or my tool or my instrument or my test for students, maybe my mathematics aptitude test is valid, you're saying it's valid for its intended use or its intention. So it's evidence of a given or specific interpretation. We want types of validity evidence rather than just types of validity. Previously, your textbook kind of reflects this as well. It sort of talks about types of validity, but it's really validity evidence, types of validity evidence that we're gathering. If you'd like more references on this, you can easily check out the Standards of Educational and Psychological Testing. So beyond just measuring what it is designed to measure, we think about validity as the degree to which evidence and theory support the interpretations of test scores for proposed uses of that test. It is the interpretations of test scores for proposed use that are evaluated, not the test itself. Statements about validity should refer to particular interpretations for specified uses. Although in general we're going to cover the same forms of validity, the same evidence for validity as in your textbook, I like to situate it a little differently and start off with face validity, because this is what many of us are expecting to see. That is, test items to appear to measure the construct that we're interested in, the idea, the area, the domain that we're interested in. The item content at the surface level appears to measure those things. There's no depth of investigation here. You can see my little silly cartoon here about whether this is a trick question, because it's not always necessary or desirable to have this face validity. It's probably more true in the psychological tests because people will begin faking it. That is, if there's a psychological evaluation being done, we may fake a specific profile. And actually, sometimes that's used in the batteries of tests and assessments that are given in psychology. We sometimes use whether or not a question looks like it measures what it's supposed to determine whether someone's trying to fake some sort of psychological diagnosis. Now, the first of our more formal evidence for validity is content validity. This goes beyond just face validity. This is a logical process. It deals with the adequacy of content being sampled with respect to the domain of skills, tasks, and knowledges that we're evaluating. We provide evidence for validity of achievement tests and certification exams, and those are often rooted in this idea of content-related evidence. Evidence based on content validity. Content validity was one of our classical three types of validity. That is content validity, criterion-related validity, and construct validity. Now for all three, we discuss them as evidence for validity, or evidence based on, in this case, content validity. We want to know whether test items are judged, when judged by independent subject matter experts, SMEs, match the content domain. So this is going to be content-oriented evidence. We may have judges, such as a panel of judges, helping us evaluate our items or objects and how they match. It could be a specialist in an area, whether it's martial arts or cookies. And you could have the national experts. In this case, the Supreme Court judges might be helpful if we were building a test on the Constitution. Of course, this is a really good place to start thinking about your research question. You know, for my research question, I'm giving some sort of math assessment or math test. So I may anchor the type of test that I'm developing, and I first might ask, are these the type of problems that 7th graders should know? Who can help me determine what the test material should be? Who are those subject matter experts? What's the type of analysis of the domain, the content domain that I could uncover? The content domain in this case is mathematics for 7th graders. So I may talk to teachers and administrators and those that are familiar with the content area in developing that type of assessment, or selecting the type of assessment that may already be written or already exists, the instrument that already exists in this case for the mathematical assessment that I might use in my research. So this is a great opportunity for you to hit pause and think about types of assessments or instruments, survey questionnaires that may have already been developed, or what you might do, and who are the experts you would need to pull together if you're developing your own instrument. Test criterion relationships. We can think, how accurately do test scores predict some sort of, or associated with some sort of external criterion? Think of those as other measures of the same construct we are interested in studying. This test is not a measure of a criterion, but rather it is a measure hypothesized as a potential predictor of that target criterion. Two approaches are predictive study, which is a criterion scores are obtained at a later time, or concurrent study, which we get obtained scores and criterion information at the same time. You can think about this as predictive evidence for predictive validity measured in the future, or evidence for concurrent validity measured at the same time. So instead of a logical method like we had with content-related validity, we have an empirical method, which should also start leaning you toward the idea that you can do multiple different forms of evidence at the same time. As a matter of fact, one should, if at best practice, provide multiple forms of evidence for the validity of their use of their test scores. So here we're establishing validity through a comparison, and we can either do it in a concurrent or predictive manner. In the concurrent, as I stated before, it's done at the same time, and it's usually based on established or an existing situation. An example that we see in our book is that we have a standardized exam that already exists. We know it's valid, and we can develop our own exam. So we could do this with my math. I could then relate this to my math example. Perhaps I know that there's an established standardized mathematics achievement test. I develop a very simple mathematical assessment for my 7th graders in my research, and I could relate the two to see if I have concurrent evidence for validity. Whereas for predictive validity, it deals with something that is likely to happen in the future. An example we have from our book is the performance on a screening test for a word processing specialist to a measure of job performance 6 months later. So we may be having a brief assessment, my mathematical assessment. If I were to look at it as predictive, it might be giving that short mathematical assessment in my research. And if I were using that for predictive validity later, it might be like grades or in the actual mathematics course that comes at the end of the semester or the end of the year. We also, in our text and in our readings, discuss a little bit of construct-related validity or construct-related evidence. This is the extent to which an instrument used measures the theoretical or hypothetical construct, factor, or trait that's in the domains that we're interested in. You can think about it as a construction that explains some phenomena. We have hypothetical constructs here. They may not necessarily be considered real objects or events. So, for example, theories of learning, they involve several different types of constructs. Motivation is a construct, intelligence is a construct, and anxiety is a construct. When considering constructs, we're almost always dealing with unobservable measures. So I use optimism as an example here. Imagine you're interested in optimism. And specifically, we're going to define that as one's expectation of positive future experiences. We cannot touch, see, or directly observe tangible optimism. Instead, optimism is an unobservable latent construct, a latent variable, a factor. We say things like, we are highly optimistic, or very low optimistic, have very low optimistic expectations. So optimism may or may not be real, but we create this construct, this idea around our definitions. And as we discussed earlier in the semester, we begin constructing operational definitions. How are we going to measure this thing that we can't see or observe? In order to measure our constructs, we have to have manifest variables. We have to have variables that we can actually see, measure, observe. So to measure optimism, we need to examine behaviors or tasks that can infer the existence of the unobservable phenomena that is optimism. In psychology and educational research, constructs are often not directly observable. You do not ever observe mathematical ability. You observe the items someone is responding to in a math test. In optimism, we don't observe optimism usually directly, but there's usually some sort of report. These go back to our idea of operational definitions, and the reason why we often are doing operational definitions is because we have a construct that we want to investigate. We also call constructs sometimes latent variables. So for example, we can collect data as observations through behaviors. We can observe behaviors. We can get self-reports, questionnaires, and other types of instrumentation, in this case for optimism, to try and uncover someone's perspective or someone's measure on optimism. In general, the idea is that we're relating manifest variables to some sort of latent, unseen construct through some scale, through some scaling technique. And our constructs fall typically within a theoretical framework. Why do I bring up construct validity the way that I did? Because all of our validity, all of the measurements that we take, all of the evidence that we build, whether it was based on content relationships or criterion evidence or building operational definitions, all of our validity is also some form of construct validity. Samuel Messick comes up with this notion of a unified form of validity, and he unifies all of our different evidence for validity under construct validity. In order to collect any forms of evidence that we've discussed or other forms of evidence that exist for validating your instrument, for developing evidence for the validity of the scores that you want to use, in all of those cases, you must have a theoretical framework, a theoretical structure in which you're working under. You build ideas about the relationships of the content or external criterion within a theoretical frame. All of their evidence is going to be nested in this idea of constructs and theory. Putting reliability and validity is necessary. You cannot have validity without reliability. Reliability is consistency and repeatability. Validity is that we're measuring what we expect to measure. We're expecting what we intended to measure, what we developed an instrument to do. So it's important to do both. We need to have valid instruments that are also reliable. It's also necessary, after we've discussed reliability and validity, it's necessary I just want to put a note out here, a little discussion here on fairness. Without fairness, you don't have a valid assessment. Fairness, we can think about it, we'll just take these 4 general bins of fairness that are related back to the standards of educational and psychological measurement. Fairness in treatment during a testing process is that all test takers have the same environment, they have the same time limits, equipment, whatever it is you're considering in your environment as you're doing research or under an assessment, except if there's a valid reason to provide an accommodation for someone. If someone needs an accommodation for learning, then you may add extra time. But that needs to be well documented and defined, and fairness should be equal amongst all of our participants. Fairness can also be seen as lack of measurement bias. If we were going to dive deeper into our measurement bias, we would talk about differential item functioning and differential test functioning and predictive bias. In general, we would be saying things like, we expect when 2 people have the same general ability levels, true ability levels, that items should function the same way for them, regardless of who they are. We also want to make sure that there's fairness in access to the constructs as measured. This means making sure to take into account age, race, ethnicity, socioeconomic status, cultural background, disabilities, English language proficiency, and how they may affect the accessibility to the measured constructs. And we also discuss fairness as validity of individual test score interpretations for their intended uses. So we're going to consider the individual test taker and how characteristics of that person may conflict with the test and its administration. These ideas of fairness need to be taken into account. There are two different worldviews of fairness. There is that fairness is its very own separate pillar and its own separate, that it must be accounted for separately. And then there's the other view that fairness is sort of underpins validity. It actually doesn't matter which of the two it is from a development standpoint. You must take fairness into account as you're developing a test, an instrument, even our questionnaires. You should be considering those issues of fairness as an instrument and assessment is developed. I like to just hang out with this slide for a second as we think about fairness for selection. This is a really good example. Please climb that tree, right? That's all the test. Everyone gets the same test. But then you have to really start to think if this test is fair. So I'll just sort of like hang that out there for a second, let you think about it. As we think about fairness, I'll come back to our reliability and validity slide here where we're trying to hit a target. I mean, it's pretty clear of a construct if you're trying to hit a bullseye and you have a bow and arrow or darts. But we might think about the instruments that we're using as our education, right? So someone may have a very robust and expensive education where they have this, I use a crossbow with a sight here, a compound crossbow with a sight, where one can really use that over time and really learn that instrument well. Whereas the longbow, one can learn that, use that too, but there's certainly an advantage to having the high-powered and expensive crossbow here versus the longbow, the traditional, an older weapon type, which may not be as expensive, may not have as much reliability and accuracy. We might think of these as analogies to things like access to education, socioeconomic status. So I just give that as an example. When we start to think about fairness in assessment, we should really be thinking about the whole social construct of a person, especially when we get into formal testing. When we're doing questionnaires, we still want to be thoughtful about fairness. You may not dig as deeply into it, but you really need to be thinking about different social constructs, economic issues that can arise in individuals, because it's also to your advantage in giving out question instruments and inventories, because you want people to respond and you want people to be thoughtful in their responses, and you don't want to lead toward bias issues. We're moving away from our desirable characteristics of measurement, and now we're going to talk a little bit about tests and inventories that we may actually use in measurement. So this is a good opportunity as you're thinking about your research design. What type of test or instrument might be involved in your research, if any? You may have other observational methods that you might be using. We often think about achievement tests, probably reflective of some of our standardized tests and assessments that we use. And there's different ways of examining our tests and comparing individuals. There are the general norm reference tests. These are performances is compared to the performance of a normative group. So we may go out, collect data, build a normative group, build a group to which we want to compare other individuals, and we can get things like percentile ranks and other types of things in order to compare individuals across a spectrum. Other types of achievement tests may focus on a particular set of skills without a reference group. For norm referencing, we call this usually a criterion reference test. This is where we have a measure of success. We want to usually have some sort of cut point assessment for success, and we set thresholds in there, like some sort of performance threshold. In our proficiency test, there's usually a specific standard or acceptable performance that we're looking to examine. So these three achievement tests, one of the things to think about is that you may have a norm reference test that is also criterion referenced, or a norm reference test that's also a proficiency test. So some of the lines here blur a little on the actual assessment side, but in the development of the test, you can have norm reference, criterion reference, and proficiency tests. In considering some achievement tests, and here we're just kind of focused in on academic skills and achievements, but in general with achievement tests, you want to make sure that if there is a standardized test you're using to check the appropriateness of this. Often these are very effective in research, but they may be very long. So you may consider either taking a shortened version of it or maybe even developing your own. But one thing to note, that published tests are well constructed, which means they have those desirable characteristics of an assessment or a test or an inventory that we already would like. So that's true of all of our inventories and tests. Self-constructed achievement tests, you should closely reflect the objectives of the research that we're interested in. You can establish validity or evidence for validity through logical processes or piloting empirical data, just like you would with a more formal assessment or achievement test. But be cautious, because this is an area where often people don't have resources or time to actually develop the validity prior to actually using the self-constructed achievement test. And then reliability can be checked pretty easily during the research process empirically. Actually, reliability is relatively easy to assess as we go through. So you may have a simple mathematical achievement test that you've developed. You can see whether it's reliable. And then often validity will be more of the logical process, anchored in the content of a course, anchored in maybe a relationship to some other assessments. But often, it's very useful if one can use some standardized assessments in their research. They do. But I just kind of leave this out there. The pause button's been up because as we go through achievement tests and just other types of tests in general, sometimes we'll see the lines blur just a little bit. But also, this is a good opportunity for you to be thinking about your research and what you're measuring. So as you go through and think, am I doing an achievement test or is it more of an aptitude test? And then either way, what are the things that I should be considering? One thing about an achievement test is we're really looking to see maximum achievement, and we'll differentiate this next from an aptitude test, whereas we're looking more for potential. Aptitude tests are another type of test we're probably familiar with. You can think about the Wechsler intelligence scales or the SATs. Their idea is that they intend to measure potential. The SATs is maybe your success through your first year of school, through your first year of college. This gives indirect evidence of existence of the potential, and sometimes it's difficult to separate out real achievement that's already occurred from the potential achievement. We also see a lot of career aptitude tests for career centers so that you get an idea of what type of job might fit you, or during an interview process to see if you are a good match for the job setting. There is often a lot of overlap between our aptitude tests and our achievement tests. That's kind of why I follow them with each other. So we would develop them and provide evidence. So one thing I want to make clear is that it's not like we're finding necessarily different pieces of evidence to support reliability and validity. We just have to be clear about their intentions. And as you're developing your research, you just want to be looking toward things like if it's potential that you want to be examining, you might be looking and leaning towards some of the aptitude tests and inventories or scales. Whereas if it's an actual achievement in K through 12 or maybe a mathematical performance and ability, you might just be looking toward those other types of achievement tests. So really the differentiation here is also more for what we might consider whether we're considering potential or actual ability, but also as a researcher, if you're looking to, what matches your research questions and your dependent variables, you might think, am I looking more for aptitude or potentiality, or am I looking for actual achievement and actual maximum achievement that already has occurred? So this is the idea of separating achievement from potential. In considering person's feelings or attitudes, you may develop or use an attitude inventory. The difference between achievement tests are towards someone's best or maximum performance. An aptitude test, we said, was toward their potential. And an attitude is really, what is their typical performance or stance? These are always feelings towards something. Attitudes are always someone's feeling towards an idea or concept, a procedure, social institute. And often we have to construct these ourselves. There are very good instruments out there, but often if we have a specific attitude we're looking to consider in our research, we often may have to develop our own attitude inventory. Here's just a really simple attitude scale. You would use this inventory to build, an attitude toward elementary reading. So, our attitude is always towards something. We're looking for some typical responses. How do you feel when you read a book on a rainy Saturday? How do you feel when you read a book in school during free time, etc.? So this attitude inventory would sort of get at some of their feelings, their elementary reading attitude, their feelings toward reading. When it comes to scaling our types of attitudes, one of them probably most familiar to you, whether you know its name or not, is the Likert scale. Usually we have 3 to 7 points on a Likert scale. Typical is 5. Sometimes you see 4 where someone's forced not to give an opinion. Forced to give an opinion. They can't leave no opinion. Here's a little example. I am easygoing. I have high standards. I enjoy time alone. You see that we have a strongly agree to strongly disagree scale. In this case, it's a 5-point scale. We may assign numeric values to each one of those points. Maybe starting with strongly disagree, we might assign 0, and then somewhat disagree be 1, no opinion be 2, somewhat agree is 3, and strongly agree is 4. So we can total those values, come up with an attitude scale here. And you have to be careful because response can be faked. You could go through and try and fake a stance or a perspective. So I may not believe I am easygoing or I have high standards, and I may fake a scale because for whatever reason. Other types of scaling we sometimes see is semantic differential. This is just a series of bipolar adjective scales related to a word or concept to measure the connotative meaning of the concept. So respondents indicate their feeling on the continuum. So we may go closer, for example, your view of college, it's necessary for a career, or not necessary. So you may just kind of mark where you are relative between those two concepts. You have some examples of rating scales in your book. Rating scales basically are how items are related to a concept, and we select a descriptor that approximates a person's assessment. Here, this is a pretty popular one used in hospitals or a doctor's office, talking about pain. So if you select 0, you have no pain. 10 is the worst possible pain you could ever feel. And they give you kind of sample smiley or frowny faces to select from to see how much pain you might be in. So that although this isn't in words like less than, it is also in words, but it's not just in words. Sometimes these types of scales are very effective when put together with other measures. Just another way we might consider collecting data in our research is observation systems. These are methods of data collection that is recorded by an observer, used for recording pre-selected behaviors to attempt to quantify behavior. And we may have high inference cases and low inference cases. High inference cases are that the observed behaviors are judged qualitatively and proper ranking is inferred. There's a lot of demand. It's high inference is actually high demand on the observer. So maybe we might see this in like a job performance review where someone has to evaluate an individual qualitatively. Low inference is that the observer notes presence or absence of a particular behavior without having to judge how much or how well something is done. You can think like the observer demand is very low, somebody could just have a check mark. There's a lot of developmental benchmarks we might look for in young children and just see whether or not that we observe or do not observe the behavior. There's still some inference to be drawn whether or not we actually observe the behavior, but the demand is low. So when you start to think about inventories and where to find information on our tests, our assessments, the questionnaires we might have, your answer is the internet. That's where I go. That's where our resources are available. So for example, there's tests in print that's available. A lot of the resources mentioned in your textbook are just right available online through the bureaus.org. ETS, we can go to ets.org for our test collections. You can look up dissertation abstracts, as well as use journals that are relevant in the field. I'll try and come back to scoring, data preparation, coding, those things that are relevant as we look at maybe a more realistic example. But just kind of to touch on some of these ideas, we need to make sure that we have accurate and consistent scoring before we do an analysis. So you want to go through, you want to make sure there's no mistakes in your data code book and your data that you've acquired. When you're using a standardized test, it typically uses a standardized scoring. You want to make sure you follow the rules of scoring. Self-developed instruments, if you develop your own, you must use and define, operationalize your scores, such as whatever analytic techniques you're using, or if you have rubrics, you need to make sure that those are available and part of your methods. And in coding, you want to make sure that you've developed the format by which data are specified and organized in preparation for the analysis. In summary, we really focused on measurement, reliability, and validity. We touched on some fairness issues, looked through some of the types of tests and inventories. In general, you might use naming a few specifics and some locations where you could find them. And our intro to data preparation, we're going to touch a little bit more on that in a separate video, and as we move forward into our statistical lessons. Next up are going to be descriptive statistics, followed by a lecture in inferential statistics, 2 separate lectures. These are just introductory ideas. That doesn't mean it's an introductory course in statistics. This is not that. As described earlier in the semester, we're just going to be briefly covering areas of statistics. Now, descriptive statistics, there's really not so much to go over even in our intro courses. We usually wrap together an introductory course. We'll wrap together usually descriptive statistics with a little introduction to inferential statistics. And then our second and third introductory courses in our series here at the university go into analysis of variance and regression. So there's 3 courses really that cover the details of those 2 chapters in much more depth. We are not doing that here. That is not to say we're not going to be doing some of the mathematics. We'll calculate out a mean and a standard deviation. We'll look at a z-test and a t-test. But we're not going into the depths we would in a traditional introductory course. But still be prepared, read the chapters, we'll follow a lot of that information, and I will try to parse that out in our lectures on descriptive statistics and separately on inferential statistics.